For this problem, you need to identify what quadrant each of the given vectors is in, and you need to state the angle that will correctly express the direction of the given vector. So the approach that I recommend is drawing the vector. I'm going to start with vector A. So if I draw vector A, it's pointing up and to the right. So you're going to start from I've got my Cartesian coordinate system here. I've got my two axes that are perpendicular, the vertical and the horizontal. And I'm going to start drawing my vector from the origin. So the vector is going up and to the right. So I draw it like so. And then the angle here, this 50 degrees, this is the angle between the vector and this dotted line. And hopefully you've noticed that this dotted line is horizontal, just like the x-axis, or sometimes we refer to this as the horizontal axis. So 50 degrees is right there. That's 50 degrees. This angle is pointing up and to the right, and it's quite obvious when you draw it from the origin that it is pointing in the first quadrant. This is quadrant 1, of course. This is quadrant 2, 3, and 4. Let me quickly label those just so there's no confusion. This is 1, 2, 3, and 4. Now, it also says here for the angle, and so by the way, I should say that I would go here and I would choose quadrant 1 because that's what quadrant it's in. Now here it says the direction, we want the angle east of north. Okay, so this is north, this is south, this is east, this is west. So east of north, that means you have some direction of some other direction. That means you start at the last direction. So this is the last of the two directions stated, north. So that means I start north and I go east. If it said west of north, I would start north and I would go west. If it said south of east, I would start east and I would go south until I hit the vector. But here it says east of north, so I'm going to start at north and I'm going to go east. And so how many degrees do I have to go? And the answer, hopefully you can see, because the angle between the north axis and the east axis has to be 90. We know that our horizontal and vertical axes are perpendicular. That means this has to be 40 degrees. 40 plus 50 is 90. So this is the answer here, 40 degrees east of north. And I should note, with regards to these directions, and by directions I mean north, east, west, and south, when it's phrased this way, east of north, west of north, south of west, your angle is going to be between 0 and 90 degrees. It can't be 90 or greater, and it's not going to be 0 or less than that. It's got to be between 0 and 90. Now for vector B, this one is going down and to the left. So let me draw that one down and to the left. And again, I'm starting from the origin. So down and to the left. There we go. 80 degrees. That's, once again, dotted line up here. The 80 degrees is the angle between the dotted line and my vector. The dotted line is horizontal. So this is the angle to the horizontal, or relative to the horizontal. And so you can see down and to the left is quadrant 3. It's quite obvious it's pointing in quadrant 3 based on how I drew it. So I would choose quadrant 3 right here. Now I got to get the direction. It says relative to the horizontal in the chosen quadrant. So we're talking about in quadrant 3. Again, that means the angle has to be between 0 and 90. So relative to the horizontal, well, I already know that. It's 80. So I can go ahead and write that down. 80 degrees. Now let's do vector C. So vector C is up and to the left. So up and to the left. Oops. Undo that. There we go. Up and to the left. And here you could see the dotted line, instead of being horizontal as it was for A and B, the dotted line is straight up and down, in other words, vertical. So this 30 degrees is between the vertical and my vector. Okay, so here's the vertical, here's the vector. 30 degrees. Now, I know some people get bothered by the fact that here, this dotted line, see how it connects to the head of the vector? And here, this vertical line is connecting to the tail. It doesn't matter. It doesn't matter where my vertical lines intersect this vector. Okay. It doesn't matter. Wherever it intersects, that small angle, all these small angles I'm indicating, those would be 30 degrees. And that comes from geometry. It's parallel lines. You have one line intersecting several parallel lines. That's why it's going to be 30. You don't need to remember the geometry. You just need to remember that, hey, it doesn't matter that the vertical line is here. It's going to be 30 degrees between that vector and any vertical line. And here, this is going to be between the angle between this vector and any horizontal line is going to be 80 degrees. So that just, again, comes from geometry. So I've labeled my 30 degrees. Now, once the angle relative to the vertical in the chosen quadrant, okay, great. I actually already know that. It's going to be 30 degrees. Now, if by some chance it said relative to the horizontal, well, then I would need this angle here. I would need this angle right here, which of course would be 60, because this angle plus this angle has to add up to 90. And once again, this angle here for vector C, it's got to be between 0 and 90, because it's relative to the vertical in the chosen quadrant. In a chosen quadrant, I've only got 90 degrees of separation to work with. Technically less than that. Okay, so the last one is vector D. So I'm going to draw that separately. I'm going to draw that in this other grid that I have, this other coordinate system. And I want, let's see, it's down and to the right. So I start from the origin, draw down and to the right. There we go. All right. And the angle I'm given is between the vector and the vertical. And I'm told that's 40 degrees, so I know that this angle, the angle between the vector and the vertical, is 40 degrees. And it wants clockwise from the negative y-axis for me. So here's the negative y-axis, and this is clockwise. So that means I have to go all the way around, like so. That's what it means. I have to start here at the negative y-axis, and then I have to go around until I hit my vector. Now in this case, you might have something worded differently here. It might say counterclockwise from the positive x-axis or something like that, okay? The answer here is going to range between 0 and 360 degrees, just so you know. In my case, it's going to be quite large because I have to go almost all the way around. Now, you've got to reason through it yourself for your given vector. In my case, I've got a couple of choices here. The first choice that comes to mind for me is I know that if I go all the way around, that's 360 degrees. So 360, but I don't actually want to go all the way around, do I? I want to go 40 degrees less than all the way around. So I've got to subtract 40, and that gives me 320 degrees. And that is actually the correct answer. But that's not the only way to approach it. I could instead say, look, I'm going 90, 180, 270 to get to here. So it's 270 to go from the negative y all the way around to the positive x. That's 270 degrees. And then I need to go a little bit more. Well, how much more? Well, I know this angle is 40. And since I know that this angle and this angle have to add up to 90, then I know that this angle is 50. So I could go 270 plus 50. That's another way I could reason through this. And of course, 270 plus 50 is 320. So I still get the same answer, of course. But as I said, you need to look at your vector and you need to reason through it as best you can. So this is how you do the first part. Let me go down to the second part now. It says express the direction 339 degrees clockwise from the negative x-axis in the following different ways. Okay, so similar approach to what we were just doing. First, I'm going to draw my vector, so I'm drawing my axes. And then I'm going to go ahead and draw my vector. It says 339 degrees clockwise from the negative x-axis. So I've got to start at the negative x-axis, 90, 180, 270. So 339 is somewhere down here in the third quadrant. Okay. And I know that this angle right there, that's 339 degrees. Now, right off the bat, it says south of west. I need to express the direction of this vector in terms of south of west. So there's north, east, west, south. Okay, so south of west, here's south, here's west. So that means I have to start at west and go south. So this is the angle that I need to find right here. Okay, I have a couple of ways of getting that. The first way that comes to mind is actually the approach I was just doing. I know all the way around is 360, but I don't want to go that far. I only want to go, well, I'm saying this incorrectly. Let me start this again. I know all the way around is 360, and I know this is 339. So whatever is missing must be the difference between those two angles. So I know that 360 minus 339, which is 21 degrees, okay? So that's 21 degrees south of west. That's this angle right there, 21 degrees. And of course, you've got to go through the reasoning for your own. You may not be doing this same kind of math to get your answer. This is just one example, but you have to reason through it using the relationships that you know exist in the Cartesian coordinate system, that the axes are perpendicular, going from a positive axis to the negative axis, or vice versa, that's 180 degrees, going 3/4 of the way around is 270. You know, you need to take advantage of these relationships. All the way around is 360. But let's continue on below the negative x-axis. Okay, this is the negative x-axis going below. Well, I'm just going down 21 degrees. So that's 21. Left of the vertical in quadrant 3. Okay, here's the vertical. So if I'm going left, how many degrees left do I have to go? Well, I don't know that yet, but I do know this is 21 degrees, and I know that this angle plus this angle has to equal 90. Okay? So going through and doing that math, that's going to make this 69 degrees. So that means I have to go 69 degrees left of the vertical in quadrant 3. And the last thing is counterclockwise from the negative y-axis. Okay, so the negative y-axis is right here. Going counterclockwise is this direction. So I have to go all the way around. I'm going to draw this in a different color so it stands out for us. I need to go all the way around like that. So a couple different ways I can do this, but the way that immediately comes to mind for me is I know that this is 90, 180, 270, plus this little extra, which is 21. So I know I'm going to do 270 plus 21, and that, of course, is 291. So this is 291 degrees. Alternatively, I could have said I'm going all the way around to 360, but then I need to subtract this 69 to get to my vector. That would be 360 minus 69, and of course, if you do that, it works out to be 291 degrees.